Hi everybody, I'm Kwabena with OpenMV, and today I just want to show off the OpenMVCam AE3 running and some of the cool AI model examples that we've got now working with the system. So before, when we launched the Kickstarter, we just had YOLO V8 and YOLO V5 and 2 models running on board. And so we've taken some time to input a few more interesting ones, in particular Google Media Pipe networks. So let's check it out. First one here is BlazeFace. So BlazeFace is an awesome facial detection network. As you can see, it really handles my face. It does not crap out like the Hard Cascade. This model actually runs on all our OpenMV cams, and so you'll find this available now once we get our latest firmware release out. This will run on every camera that we support that has our AI ML framework built in. So pretty much everything back to except for the OpenMVCam 2, the original version of it. But on the H7 Plus and RT1062, our modern OpenMV cams, it's going to run about 2 frames a second on board. Not amazing, but good enough to actually get something done with. And the detection rate is a lot better than Hard Cascades. As you can see from the AI here, it's actually able to detect key points. And so we've got our ears, eyes, nose, and mouth. And this is a multi-face detection model too, so it's going to find more than just me here. All right. Besides for this network, we're also going to be integrating eye landmarks tracking in the future. And so eye landmarks tracking is actually going to go beyond just finding where the eye kind of is. This will actually give you a list of points kind of directly around every little position in the eye, along with really being accurate on the centroid of where your eye is looking. With that kind of detection network, you're actually going to be able to do two things. One, finally measure gaze detection, which is what people have asked us for forever with our camera. And also, you're going to be able to measure the distance of that face away from the camera, because the eye, a person's eye, generally are about the same size across people. And so using that along with the camera intrinsics, you can kind of estimate how far away that person is then from the camera with millimeter level accuracy. Moving on, we've also got something awesome called palm detection running on board. So with palm detection, you're going to be able to detect where your palms are in the field of view and the back of your palms. This is another Google Media Pipe network. And so this guy actually gives you your location of kind of your knuckles, your thumbs, and etc. It's pretty awesome. But it's even better when you combine it with true hand landmark detection. And so here we go. Now you're starting to see the power of the OpenMVCam AE3 and what it means to run AI models on the edge. So the hand landmarks, this is running 2 models composed. First, we're doing palm detection to find palms. And then after that, we enlarge the region of interest and we run something called a hand landmarks detector. And so this takes the palm location and then gives you a very, very nice list of hand landmarks, pretty much all our finger joints. As you can see, it's a lot better and a lot more robust at tracking those key points than the basic network, which is a little bit more fuzzy. Of course, palm detection, though, requires palms to exist, so it's going to kind of fail if you don't really have a palm showing or the back of your hand. But it's still awesome in that we can see both our left and right hands, and we can see our digits as we move it around. Now, we can do better, though. If you remove the palm detector network running every single frame, you can actually get a lot faster FPS. What we're doing now is, instead of supporting 2 hands at once, we're just doing 1. And this is just repeatedly running the hand landmarks detector over and over again on the same region of interest where a palm was previously detected. As you can see with this, we really got all of our joints, and you can see it's able to update quickly, figure out where everything is. And so we're using this network, then we can actually do actual digit classification of what your gesture is. There's actually more networks that we'll have to integrate to make that work. So Google has an AI network that then takes the 21 key points you see here. And once it takes those 21 key points, it'll actually output a 128-bit feature vector. 128 floating point value feature vector. And that feature vector then, once you have that, that can be then used to run off a final 4th network that will actually do kind of your classification, mapping something in that 128 floating point vector space into a class of like, hey, thumbs up, pointer, thumbs down, etc. So Google has a simple model that they have built and that will support in the future that just does about 7 different hand gestures and etc. that we'll be able to run on board for demo purposes. But then if you want to go farther, Google has everything necessary for you to collect your own gestures and train your own custom model to do more than just 7 different types of hand positions and etc. But moving on, we've also got stuff like facial landmarks. So with this network, what we're actually doing now is we run BlazeFace to detect where your face is in the field of view. And then facial landmarks actually finds and draws about 468 key points that represent facial landmarks. And as you can see, it's going and it's finding me and it's drawing those facial landmarks. So this type of network is typically used to actually just kind of display like a 3D mask on people for like your Snapchat filter and etc. But we've got it running on the OpenMVCam now too, and we're excited to see what people are going to be able to do with it. Now, by default, the facial landmarks themselves aren't too useful, but just like we mentioned with the palm detector, you can run these 468 key points through secondary neural networks that'll then be able to break this down into feature vectors so that you can then classify expressions and etc. And Google actually also has a model, a little bit more advanced one than this facial landmarks model that actually it actually outputs a second list of classes that kind of tell you what that face is doing. So not necessarily happy or sad, but it outputs stuff like eyebrow raised or eyebrow lowered or mouth open or smile or etc. And that AI model is meant to be used for then actually like animating those 3D masks that you would put on somebody so that you can actually like make the mask change in response to different behavior happening and so on and so forth. But we're excited where this is going to lead to and what you're going to be able to do with the ability to run facial landmarks on board. And then also, just like we mentioned with the palm detector, you can run this without having to do the BlazeFace detection over and over again. And so cutting out BlazeFace and just running the landmark detector on the previously detected ROI gives you a minor speed bump. And this can be used, this of course only finds one face versus multiples. Finally, we've got some AI models, a new one called YOLO LC. And so this model runs on board all of our OpenMVCams, and it's a person detector. But this is a huge upgrade from the Google person detector that we previously shipped that just does person or no person in the field of view. This is actually a full object classifier. And so this will find a person in the field of view and draw a bounding box around them. And as you can see, it runs at about 60 FPS on board the OpenMVCam AE3, and it'll run even faster on the OpenMVCam N6. Best of all, though, this network actually runs on your OpenMVCam RT and H7 Plus, and you get about 2 frames a second on board those. And so that means we have an actual person detector network for those cameras that does object localization. Awesome. But for actual good performance, we recommend running the YOLO V8 model. And so this is our standard person detector YOLO V8. As you can see, the bounding box a lot better than the YOLO LC. Perfectly kind of finds me. As you can see, the bounding box really kind of grows for my hands and it's not kind of random all over the place and etc. So we've got it. These are sweet networks running on board. And if you checked out the RoboFlow demo before, you can see where we're going here, where you can actually now train your own AI models. Anyway, we're going to be launching more AI models on board the OpenMVCam as time goes on. So again, eye landmarks coming soon, followed by also MoveNet, which will do your full body pose and etc. And then we're going to be adding classification networks that take the key point outputs and then actually figure out what to do with those so that you can have actual classification results and not just a bunch of key points. Anyway, and then also image segmentation networks, of course, instance and semantic segmentation. So we're going to be offering the full gamut here. And it's going to be awesome. So thank you for watching and get excited.